Hello and welcome to today's very important and interesting session on Azure Kubernetes Services Design Consideration. And before I actually go into the considerations here, let me take a brief moment of introducing myself. My name is Atul Raizada. I am an Azure Cloud Solution Architect expert and Azure Cloud Solution certified security engineer. Creating these technical videos is one of my hobby or passion. I have been doing it for last about 2 years. And if you are watching this video for the first time, I strongly recommend and encourage you to look for my name and my channel on YouTube, and you may find several other topics, several other deep dive technical demos that may be of interest and may be helpful to you. With that, let's just start the session. And before we actually go into the topics and deep dive of these considerations, as you know that I said that this is a very important and interesting conversation or session today because of a couple of reasons. First, many of you probably would agree with me that Kubernetes is one of the hottest topic of when we talk about cloud or modern software engineering today. I hope you agree with me. The second is that when you start looking into Azure Kubernetes services and you start planning and designing, it is very hard and difficult to find one single presentation, one single documentation around all the different elements that organizations or you should consider it when you're planning or defining the strategy for deploying Azure Kubernetes services as your overarching modern software engineering IT roadmap, right? And what I'm trying to do here, hopefully, that I would fill that gap, and this presentation would provide you all the necessary element that you and your organization should be thinking, planning, defining in your modern software engineering roadmap. With that, let's get into the actual session. So this is a very busy slide, and you would see that this particular video, this particular session would cover a lot of topics. I would not read them. I hate these busy slides, but the point here is that we need to talk about all these different elements before you decide and plan and define your Azure Kubernetes Services strategy. And instead of I read it all that for you and bore you, I may request you to please pause it here and go through these bullet points and try to make a sense of it. Some of you may already be familiar with that, and some of you may not be familiar with this. You may actually understand from here that this is a very advanced session, and if you are new to Azure Kubernetes services and you have never uh, done any work on Azure Kubernetes services, I would strongly recommend you to please watch my another video on introduction of Azure Kubernetes services before you actually come into this session, right? So because this would be touching very high level and very advanced Azure Kubernetes services stuff, right? So I'm not going to waste your time here and read all that bullet points. I would leave it to you to understand it. At the same time, I also want to take a moment here to set the expectations, right? I would be attaching the PDF version of this slide presentation in the description section of my video YouTube presentation. And secondly, that because there's too many topics here, this is going to be at least an hour-long video. I may not go into more granularity and deep dive discussion on each of these topics, and I would try to give you the required links on most of these elements that we are going to talk about, and that you could look at it, you could go and click it and get more detailed information that how you would be doing. So as a matter of fact, unlike most of my other technical videos where I do a technical deep dive demo, this would not be a demo. This would be more a discussion and a session on different elements that you should be considering, you or your organization should be considering for a successful Azure Kubernetes services deployment. With that, let's get into the first topic. And the first topic of today's Azure Kubernetes Services session is AKS Green Blue Cluster Strategy. And before I talk about this green blue strategy, let's try to understand what is the challenge that we are trying to resolve. So when you start putting your workloads on Azure Kubernetes Services cluster, one of the questions that you, your organization, your CIO, CFO may ask that, hey, what is your DR solution for these mission critical application? And as a result, you need to plan it, right? So Azure Kubernetes Services cluster do not have a built-in disaster recovery compatible a solution for you. So you might want to think about, and in that scenario, for your critical applications, you may need to consider the green blue cluster strategy. What it entails here is that you would deploy your production AKS cluster, but at the same time, you would also have a standby AKS cluster in an eventuality that you need a disaster recovery scenario, right? So basically, you would have two uh, production cluster, for the lack of better words. Now, um, it may be a good option for certain applications, certain workloads, or certain organization, but is it the final strategy? Perhaps not, because the downside here is that it would add additional cost to the organization. It would also add operational overheads, failover design complexity, networking. So it's not that very straightforward that hey, you have a standby AKS cluster and all of a sudden everything is operational. So you need to consider all those factors into your strategy. So if you ask my frank views and say what's your opinion, it's very hard for me to advise you that whether your organization would need an AKS green blue cluster strategy or not. Actually, that should come from your cloud strategy team as well as the workload. Pretty much, if you look logically, I mean, maybe that's a choice for you, or that's an option that you can put all your mission critical application that needs a DR into a separate AKS cluster and use a green blue cluster strategy, while remaining non-critical application workload is capped into a separate AKS cluster which does not uses the green blue cluster strategy, right? You could still accomplish some kind of a disaster recovery through your DevOps CI/CD process, and in an eventuality, you can recreate the cluster from DevOps process, and that is doable. But um, you or your organization have to decide whether you need and how would you use the green blue cluster strategy, and that should be one of your key strategy point when you are trying to bring the workloads into your Azure Kubernetes services. I hope that makes sense. Next important topic here from that big topic slide is the cluster isolation, right? And why would we need cluster isolation, right? So before we actually go into what are your options, most of the organizations would not deploy a cluster for one single application. That may not make sense. So as a result, you will find that one cluster may host multiple application workloads, multiple applications, multiple APIs belonging to multiple development teams, multiple departments, and that's where you have to worry about that, okay, how do I segregate them? Because as a base container strategy, you know that all containers are using one shared kernel, right? So these parts that you would be deploying for different application loads are using the same fundamental operating kernel and then the resources. So it is absolutely essential to understand that what are your options to do the isolation of these workloads, right? So we have got multiple options in Azure and in Kubernetes in general. You could do a physical isolation, which we'll talk in the next slide. You could also see the logical isolation, which we would be describing, and you could have a combination of physical isolation and logical isolation, right? So you could see that, which is a hybrid approach, and you would also do the network isolation. So when I say network isolation, as you might already know that the parts in one AKS cluster talk to each other, right? There's no restriction. But when you are putting different workloads, now you need to set the network boundaries here within the AKS cluster, that which part needs to talk to which other part. At that same time, it also brings the point that, hey, what kind of sensitive data you are bringing into the AKS cluster? Do you want to keep all your sensitive and non-sensitive data in one single AKS cluster? Probably not, right? Again, these are the key elements that you would be considering in your strategy, right? So if you have got one sensitive information which has PII or PHI information, probably you do not want to put it together with other non-critical application, right? So you may have internal application versus external applications workload that you need to plan when you're talking about overall isolation strategy. And depending on your business requirement, depending on the workloads that you have to come out with your cluster isolation strategy right up front before you actually try to implement any cluster in your organization. I hope this makes sense. Now, for your benefit, I also have given you a pros and cons of physical versus logical isolation approach in this small table here, which is self-explanatory. I really don't need to read that everything for you. You can make a good sense out of it automatically, right? Key element here to look into the cost, the security, and the blast radius of changes, right? What changes from physical to logical is self-explanatory, and that should also help you besides the distribution of your workload, that how do you want to accomplish your cluster isolation, right? So with that, let's get into the next slide. I'm gonna go try to run a little faster here because there are too many topics, and I am afraid that it's going to be too long a video that you may start losing your interest, right? Let's move on. So physical isolation is pretty straightforward. You deploy separate physical AKS cluster, Azure Kubernetes Services cluster, for each environment. This particular slide shows you have a dev cluster, you have a staging cluster, you have prod team 1 cluster, you have prod team 2 cluster. It could be very different for your organization, but you get the sense out of it, right? So is that the right strategy for you? Like, that's what I am not going to tell you, because this is what your organization or your cloud strategy has to think about it, right? But once you look all the different options, probably you and your organization can make a collective decision that what your AKS strategy is going to be, right? So that's straightforward. Let's move to the next topic, which is the logical isolation. And as you may already know, that logical isolation is achieved by through the namespaces, network policies, authentication and authorization, that is a Kubernetes RBAC. And please remember that you also have Azure RBAC and you have Kubernetes RBAC that we are going to discuss, and probably try to make sure that you understand both part of it. And you can also achieve container level isolation, which is really hard in advanced scenarios too, right? So this particular diagram here clearly defines that you have team 1, team 2, and team 3, each of them running in their own namespaces. Those namespaces may also be segregated and separated through network policies, as well as you would have different authentication and authorization to make sure that team 1 is managed by a different set of developers, team 2 is managed, or team 2 application workload is, or namespace is managed by a different set of application, so on and so forth. For team 3 maybe a different department and different development team, right? Depending on your organization, depending on how you want to do that. There's no hard and fast rule that you could come out and take it out of this presentation. These are the areas that I request and suggest that you or your organization should start thinking before you actually start getting ready for an successful AKS implementation. Moving on, the hybrid approach now I think makes sense, because you can combine and take the advantage of physical isolation as well as logical isolation. And as this diagram very clearly explains you, that you have a dev and a staging cluster, which also have been further segregated for different teams: dev team 1, staging, dev team 2. Again, this could be any structure that meets your business requirement, your workload requirement. And then you have a production cluster that is team 1, team 2, and team 3, segregated by namespaces. You could also, from the security perspective, right, when you start looking into this model, you could have more stringent and strict security controls over your prod cluster compared to dev and staging cluster. So it also gives you that kind of a flexibility in my viewpoint, right? Now, in many scenarios, this might be a good approach, but again, your strategy team, your organization has to make a decision on your AKS cluster strategy. Moving forward, the AKS resource quota, right? This is an important topic from the operations perspective. When you start putting different workloads on your Azure Kubernetes services, uh, you can find one of the application or pod that is very hungry in terms of compute resources. Generally, it is referred as a noisy neighbor situation, right? Where that particular pod is consuming your most resources on your AKS cluster, depriving you to provision additional pods or additional application and depriving existing application and impacting that performance there too. So as a AKS admin from the operations side, you need to be careful how you're going to allocate resources here. So Azure Kubernetes Services provides you a lot of functionality and a lot of options for configuring these resource quotas. One of the example is in this slide, right, where you see that we are limiting it to the CPU to 1 memory request to 1 gig and the limit memory to 2 gig. So that is the limitation here. I'm not going to go in details here, but you would see that you can limit compute resources, which includes CPU, memory, storage, and as well as objects. This is interesting, where you could also do parts and services as well, right? So you have got a lot of flexibility here to manage your resources carefully inside your AKS cluster. Having said that, it is also important that once you apply the resource quotas, your developers have to specify their requests. When they specify requests to provision new application or new pods, they have to specify the limits, right? Otherwise, if they don't, then the resource quota would not let those pods or those application provisions. So it has to be dealt very carefully, right? Because Kubernetes will not overcome it. And when you start working on it, it may be a good idea that if you have a dev environment, you keep a good eye and monitoring on your DevOps pods to make sure that you do not have a noisy neighbor situation, right? And if you have a noisy neighbor situation, obviously you need to plan for your production cluster very carefully your resource quota policies. I also have given you a tool at the bottom of this slide, which is Kube Advisor, which you can run by going to this link, and you can get more details. That would allow you to find out that which are the resources that are missing the quotas and limits too, right? So once you started having lot of application and workload in your Kubernetes services, then you probably would understand the importance of this tool, right? So it's important tool. Keep in mind, keep it in your toolkit when you're deploying the Azure Kubernetes services. Moving forward, the AKS scaling, right? Once we understood the resource quotas, then also we need to understand the scaling option. Especially this goes into the operational side of Azure Kubernetes services. And as your number of applications, instances may change, number of application altogether may change on your Azure Kubernetes services. So you may have to adjust the number of nodes, as well as you may also have to adjust the number of replica pods here, right? Depending on what your workload, it could be scale up or scale down situation. Now, Azure Kubernetes Services gives you a lot of options in terms of manually scaling, which you could manually scale the nodes. It could be an option, but it is a little tedious and difficult. We'll talk about it in the next slide. You could also do the horizontal pod autoscaler, which is pretty effective, which is generally referred as an HPA. Cluster Autoscaler is in Azure Preview mode, which may be your another tool to bring the scaling into your AKS operation sites. And we will also talk about that if you really need a very demanding application, you could also integrate Azure Container Instances with Azure Kubernetes Services, right? So without wasting any more time here, let me just get quickly into the scaling options. Manual scaling, right? As I mentioned, is tedious and ineffective. You could configure it by the links that I had given you. It also gives you you could actually do in the GUI. You can just slide the bar and change the number of nodes, or from 3 to 2 or 2 to 4, whatever you want, downsize or up, scale up or scale down. But one point that you need to remember, that whenever you increase or decrease the node, especially when you increase the node, it might take 15-20 minutes to provision that node itself and then redistribute the workload there. So it's a little bit time consuming process. It's not instantaneous, and if your application need is instantaneous compute resources, then you might need to think another option that we'll be talking about, right? So that's your manual scaling option. Moving forward, you could do the horizontal part autoscaler, which I think is a effective way of doing it. I'm not going to read all the details here. This is for you to go through it, but pretty much you would be deploying a metric server in your Azure Kubernetes side, and that metric server would be monitoring your Azure Kubernetes services pod utilization every 30 seconds, and if it finds the change, it automatically increase or decrease the number of replica required for your pod. So instead of it actually minimizes your operational overhead then when you start looking into your multiple application workloads in an AKS cluster, and it also allows you to optimize your resources properly with a kind of a built-in automation here from HPA perspective, right? I have given you the link again here at the bottom of the slide that may help you to do and to see how you can actually deploy it. And because this video is too long, I'm not going to go into the details. Actually, each topic itself that I'm talking today may require a separate session or separate demo or separate video, right? That is the intent of the complexity of um, the AKS that we are talking today. The cluster auto scaling, as I said, this is in a preview mode. You have the link. You can scale nodes based on the pending parts when you're provisioning them, when you're scaling up or scaling down. You can also reduce dependencies on monitoring. You really don't need to worry about it. It is automatically done by the Azure. Removes the need for the users to manage nodes and monitor service usage manually, right? So it is bringing the what you call required automation for scaling to your organization pretty much, right? It's straightforward. You definitely want to give it a try. Moving forward, you can bus to an Azure container instances, and what it entails, especially as I mentioned earlier, that manual scalings when you change the number of nodes could be time consuming, and if your application doesn't have that appetite to wait for that time, you can actually bus into the Azure container instances, which is readily available. And you see here in this diagram here, you have an ACI connector that connects back to the Azure container instances. And when your application needs more resources, you can immediately get that, right? So you can get that additional compute resources almost instantaneously compared to manual where it might take some time before you get it. I also have given you the link here at the bottom of the slide which may help you to understand and actually deploy or actually integrate Azure Container Instances with AKS. Moving forward, security. Huh. Nobody talks of security these days, right? I'm just kidding. So without Azure Kubernetes security, I don't think you could actually even conceive a successful deployment of your modern software engineering using Azure Kubernetes services, pretty much, right? So it's that important. And I'm not going to go into all these details that why it is so important, because as if you go back into my introductory video on Kubernetes, you may get a little bit more idea behind it. But basically, what we are trying to tackle here, that you have got different workloads with different sensitivity, and each of these application and parts are using the shared kernel, right? So that makes it a little bit more complicated, difficult from the networking perspective, from the isolation perspective, from the data privacy perspective, from the governance and compliance perspective. So unless you have considered all these elements into your from the security perspective in your AKS strategy, your AKS strategy and roadmap may not be successful, right? Including your applications layer security, which we have to talk, our API layer security that also has to be incorporated together. So let's just get into what does it actually mean in terms of a security. I hope this would help you to understand the AKS security. What I am trying to do here is I'm trying to go very chronologically here in a very systematic way that make more sense. So before we actually go to this cluster, the AKS security, this particular representation here of a Kubernetes architecture probably may be very helpful for us to define our strategy, right? So if you see here, and I would request you take a pause here and look at this diagram carefully. Very simplistic diagram, but it explains you that why each component, each element of this architecture is important from security perspective, right? So as you see here, the master node, which is actually controlling all your configuration and Azure Kubernetes services and for the entire cluster, is extremely important. It is also providing the required API server, right? That gets access to the etcd. Etcd is actually the key store that keeps the configuration setting of your entire cluster. So if somebody gets access to etcd, then we have a real trouble, right? So it could screw up your entire cluster. If the master node is messed up, then you are resulting into a total issue of the chaos for the entire AKS cluster, right? And then you go to the worker node where you have the kubelet API running. You have pod, container, and application. So we would be talking about security at each layer here instead of just going randomly, which probably may not make more sense. So we'll start with master node. We'll go with API. We'll look with the etcd store. We'll talk about the kubelet pod security, container security, and application security as well. So I hope that would make a little bit more sense when you go into this presentation, right? So talking about the master node and API server, right? So API server offers the REST API, as I mentioned earlier, and you also have to note that the kube administrator automatically disable the API server insecure port so that API access is restricted to encrypted TLS connections only. Now, when you watch my technical videos on deploying the microservices on AKS and the introduction to AKS, you will see that when the command line that we use to create an AKS cluster actually defines that variable right there, right? So you will say that the SSL set create SSL certificate there. I don't remember on top of my head, but you will see in that CLI command line, right? The important thing that is to be noted here that though you are using TLS connections here, but it is not limited by default to authenticated users. That means it is wide open, and as a result, we as a cluster admin or from the strategy point has to take care of it. We need to make sure that we take care of this control through proper authentication and authorization using Azure Active Directory and RBAC. And we use the basic security principle of setting up and keeping the least privilege access for the common task. We would also show you the admission controllers from your development perspective, which at this point is not modifiable, but you know what these controls are that you or your developer teams can take advantage of it, right? With that, let's get into the authentication and authorization. As I was mentioning that you have the ability to use Azure RBAC as well as you also have the ability to use the Kubernetes RBAC here, and together you can actually accomplish a whole lot from authentication and authorization perspective. Having said that, you could also integrate Azure Kubernetes services with Azure Active Directory. In the next slide, I'm going to be talking about it, but from purely from security and identity perspective, I think that is kind of a must where you could leverage your Azure Active Directory for all authentication purposes. That also brings additional features of Azure Active Directory like conditional access and multi-factor authentication and whatnot, right? So that I'm in my viewpoint, purely coming from security background, that is a must, and you need to add that into your command line when you actually deploy the AKS, right? So that's important topic that you should be looking into the next slide. But this particular slide on the top portion is showing you from the developer perspective, which is also taking the advantage of the Azure Active Directory authentication, as well as it is also taking the advantage of AKS RBAC, right? So if you see here, this flow is very simple. The developer comes in and request goes to authenticate to Azure Active Directory. Azure Active Directory gives the token to the user. User takes the token and presents it to the AKS cluster. AKS cluster validates it back from Azure Active Directory, and at the same time, the Kubernetes RBAC and cluster policies are applied, right here. And once this all is successfully validated, request is either successful or unsuccessful based on the processes that these steps that we have defined. Pretty straightforward. I would also show you an example of the AKS RBAC in next slide. That may explain you a little bit better. Now, when you talk about Azure level RBAC here, right? Identity and access management through AAD, Azure Active Directory, and RBAC here. Here you have a Kubernetes administrator, which goes again to Azure Active Directory, gets the token, passes the token to Azure Kubernetes services, and once administrator fetches the admin kubeconfig commands and configure RBAC roles and bindings. So this is where actually to get to the step number 2, you will use the step number 1 here, the lower portion, to create those required RBAC role, assign them to the right namespaces so that developers can start consuming the AKS cluster the way they want to, right? And that's where the segregation that we talked about, or isolation that we talked about in the first or second or third slide, also comes into picture. So that all ties it together. Now if you move forward, this is what I was talking about. Azure Kubernetes Services, AD integration, and Kubernetes RBAC. This is a detailed document, pretty simple to deploy. Actually, I strongly recommend you to go and click that link, and that would help you how to create the required application, one server and one client application in your Azure Active Directory, get those IDs, and integrate your AKS cluster with Azure Active Directory. Not very difficult, but I think that from my perspective, that is kind of a must when you start deploying AKS clusters, right? On the other side, right hand side, you will see that we are setting up a cluster role. This is a RBAC on Kubernetes side, and if you see here, we are creating this role here. I'm not going to go in detail, but if you look here carefully, that you will see the verbs here: get, list, watch, update, patch, right? You could define whatever permissions, whatever rights you need to assign to that role or give to that role, and then you can bind the role either to a user or to a group. These users are Azure Active Directory users or Azure Active Directory group because you have already integrated them here, right? And you will see the difference here, just to point out that users are being referred here as the user principal name, while the groups are referred here with the group ID, right? So once you read this article, you will get a better understanding how to leverage that. But I think this is very important for you and your organization to consider that into your AKS strategy. Moving forward, the admission controllers that I talked about, especially for your developers, as I mentioned here, that as of, as of today, they are not modifiable. These are the different admission controllers that your developers should be aware of, right? And that is what I think is important. I don't think that we need to talk much about this. This is for your information. Use it as appropriate. Moving forward, as I mentioned, and we are going again very chronologically, right? We are still on the master node, where we are now talking about etcd security, where the API actually is going to access the etcd, which is what the Kubernetes store cluster configuration and state information in a distributed key value store named etcd, right? And as I mentioned earlier, unauthorized access to the etcd may jeopardize the entire cluster, and that is why this access should be strictly limited, right? Only few people, only the cluster admins should get access to that. And that goes into an important point that we would be talking down the road in this presentation is AKS or Azure Kubernetes Services RACI. Because one of the things that I forgot to mention on the very early part of this conversation, that because this is a complex technology, right? Right from the day one when you start planning it, it has to be a collaborative effort between multiple teams. I don't think that a single entity or single team can result into a successful implementation of Azure Kubernetes services, especially for medium to large organization, right? Because You need to incorporate your networking team. You need to incorporate your security team. They need to collaborate together with your cloud strategy team, your cloud operation teams, right? DevSecOps teams, automation teams, and I would be talking about those down the road in the presentation once you see that once the racy slides come into picture, right? So keep that in mind that it is not a single one-man show here. It has to be a collaborative effort between multiple teams. Moving forward, now we get to the next layer, which is the container level security, as I mentioned earlier, where we are talking about images. Why we are talking about images? Because pretty much containers are just a software, right? We are deploying images, software images into AKS cluster. That's where the containers are created. More details, again, please go back to my introductory slide on Kubernetes where you will understand what the containers are and why I'm calling them as software. Now, when you're talking about deploying this software on the AKS cluster as images, as containers, you need to make sure that the whatever you push into AKS is is a good, verified, validated piece of software, right? If you don't, then as I mentioned, that these pods are sharing the same kernel. If something goes wrong into the AKS cluster as you are provisioning these containers or pods, and that is messed up, it is going to mess up and impact the rest of the applications and workload that you have on the AKS cluster. That's why it's extremely important to make sure that anything that you push into Azure, especially these container images, is properly validated, scanned, and you use the runtime enforcement. So if you see here, the bullet point that we need to look into is the trusted registry, which should be Azure Kubernetes Registry ACR, that we will be talking again in next few slides, and regularly apply the security updates to the container images. Why it is so important is that when the actual image was created, right, uh, that time it was healthy, it was good, it followed all the best practices. But in a few years, few months, that may not be enough, and by the time you have that has already shown some vulnerability. And if you are not applying these security updates regularly, then you are exposing your entire AKS cluster for unwanted risk. That's the reason these images has to be continuously updated. And as a matter of fact, the best practices is that you recycle these parts and application periodically, because what happens is that the old parts are removed and then you deploy the brand new parts, right? And this is a real good security best practices. It is absolutely important to scan images and containers using some third-party tools such as like Aqua or Twistlock. I'm not going to go into the details of these tools, but I strongly recommend you, if you're not familiar with these tools, please go and do a little bit more research around Aqua or Twistlock, and whatever your organization decides it, pick up a tool that you would be leveraging. You might already be using this tool in your DevOps process, probably you are not aware of it. That's where your collaboration with your DevSecOps teams comes into picture, and talk to them and find out what tools they are using, what tools they're planning to use in from their DevOps perspective that you could extend and leverage into your AKS strategy. Now, runtime enforcement and remediation. As I mentioned that because these parts and these container, or honestly speaking, this piece of software, all are accessing the shared kernel, it is important to make sure that you control that runtime process. Um, uh, you have this tool called as an AppArmor, which is not a purely a Kubernetes tool only. It is a Linux-based tool that you should use, and you should create the required profile to make sure that only specific types of pod with specific policies and profiles can only communicate with the backend kernel on your AKS cluster, right? And there's a good article on Microsoft site how to use AppArmor. I think I had given you in next few slides. If not, I would probably link that in the description of my presentation. Right. So, so what we have learned here is that you need to be absolutely sure of when you push these containers into your AKS cluster that they have been properly scanned from the code vulnerability perspective, from the malware perspective, from the security perspective, from the data governance and control perspective, that what kind of a data they are bringing into, and you also need to ensure the runtime enforcement through the AppArmor tool, right? That's the lesson from this slide. Moving forward, when we talk about the pod level security, right? So pod level security could be accomplished to the pod security context. We'll be talking about them in next few slide. Microsoft Azure is offering the pod security policies, which is in the preview mode. Always pull images, and when I say always pull images, I always pull images, only the trusted images or the signed images. We can also use pod identity using the managed services identity from Azure, which is very interesting. And we would use the pod network isolation using network policies, right? So these are few key elements of pod level security. Let's dive into very simple example for pod security. If you see here, the highlighted portion gives you the actual security context here. I'm not going to do all the reading for you, but that gives you an example that how could you do the pod security through the pod security context, right? Now, moving forward, the pod security policies, which is in the preview mode, right? It can improve the security of AKS clusters. Pod scheduling can be limited and controlled. Pod that requests resources you do not allow can't run in AKS cluster. So not every developer can come out with their own standards and start throwing their images or start trying to provision their software or application inside AKS. You have that control built in into AKS, which I strongly recommend to go and please look at this article to get acquainted with what are those options and features that you have at your fingertips. Moving forward, um, as I was mentioning earlier, that always pulled signed or trusted images only, right? So you do not want that anybody that any images can be pushed into your AKS cluster. You would ensure that only the signed images can be pushed to the can be pulled into the AKS cluster. How you can accomplish that? Again, the link is here to help you to understand that and to do that. Because as I said, we cannot accomplish all these steps in one single video here. Moving forward, the pod identity. This is an interesting area. Again, many of you who are familiar with managed services identities or MSIs or MI, this is an important area that probably you want to leverage. Basically, you could use your Azure Kubernetes Services nodes manage identity, which is a separate topic. If you have not ever implemented managed identities, I would strongly recommend to do a little bit more research. Maybe in next few weeks I would come with another video on the managed identity. So if you can wait for that, that's great. Otherwise, do the research for managed identity. But pretty much the what is happening here, there's 4 different steps actually define the whole process here, and the document or the article below would help you to actually implement it. So Kubernetes operators defines an identity map for Kubernetes services account, right? Node manage identity, which I was mentioning under, watches for the mapping reaction and sync to the managed service identity. Developer creates a pod with a service account. Pod uses standard Azure SDK to fetch the token bound to MSI. Basically, when you are trying to consume the resources which is outside AKS cluster in Azure, for an example, Azure Pass SQL or CosmoDB or storage, you can pretty much use these pod identities without actually passing a different authentication in your code, right? So you can use the managed service identity and assign that managed service identity the required rights on the required resources, and here you go. So it becomes more secure, and this is managed identities pretty much are managed by Microsoft, so it's not exposed wide. It's not exposed. It's not a regular user identity, so it's way more secure. I strongly recommend you to think about it and put it into your AKS strategy. Moving forward, AKS secret management, right? Many of you are already familiar. I think this description here is better than I read it from my mind. It defines here that a Kubernetes secret is used to inject sensitive data into pods such as access credentials or keys. Secrets are created using Kubernetes API. Actually, one of my technical video that I have on AKS microservices, you will see that I'm creating a secret there and using that secret across different YAML files to create different services, different applications, front end and back end data API and MongoDB. So if you really want to see it in action, you probably want to see that video. Um, But the key element that we are talking here from security perspective, that when you create these security the secrets, that secrets would be leveraged to consume the resources outside AKS, which could be Azure Storage, SQL Database, or Cosmos DBs. Like in another last example, we talked about uh, the same story in last slide. You can do this with the secrets too. The best practices here is to use the secrets, put the secrets into the key vault, right? And most of us are very familiar with that process. And instead of wide exposing it, developers pulls it from the key vault, leverages it, and gets the resources, required resources in Azure. Moving forward, we talked about Azure Container Registry, right? And here you go. So we already mentioned about that image scanning from the code vulnerability perspective, from the malware perspective. It would be performed through the third-party tools like Twistlock. You have got a lot of built-in Azure RBAC roles, right? ACI push, ACI pull, ACI secret, that you definitely want to look into and use the same principle of least privileges approach. I strongly recommend that you inject it into your Azure Kubernetes Services strategy. And as we talked about earlier, I cannot re-emphasize enough that unsigned images can be pushed to the Azure Container Registry. You are already seen the link and documentation around. Authentication will leverage Azure Active Directory. You have a reference document here. You also have the best practices for Azure Container Registry, which is the link given here, right? Okay, I'm gonna keep moving because it's already 46 minutes. So sorry. This is where, as I mentioned earlier, that now we are talking about DevOps, where DevOps would be, or DevSecOps, for the lack of better words, would be implementing the trusted software supply. Containers itself is a software, right? As I mentioned earlier. So unless we have a due diligent process of implementing or DevOps here to deploy these application workloads or into Azure, we might not be successful. So your DevOps, DevSecOps process, and again it goes back to the idea that I talked about, that different teams have to collaborate together for a successful implementation of AKS to adhere to your modern software engineering roadmap, right? That's exactly where it is coming into. So if you see here, implementing trusted software supply chain, uh, these are the key areas from the best practices perspective that you should be considering. Source control. So all these images that we talked about earlier should not be coming from any resource, right? So we have to control what are our key repos that you would allow in your organization as the source control. So GitHub is one of them. Do you want any developer to pull any images from third-party resources or GitHub and push it into your AKS? Perhaps not, right? So your DevOps process has to come with what is that source control, where that actual repo or repository of those codes are, or the image software or images are that you need to pull into. Obviously, once you define that proper source control, then you would define the scanning here, right? That's where we talked about the tools like Aqua and Twistlock. I'm not going to read everything for you. Run as a root user. Running container as a root is not allowed. This is a huge issue, so we need to take care of that. Image integrity control, we already discussed it a little bit, right? Not only you need to constantly keep updating images from the security vulnerability perspective, the container or the image that is safe today may not be safe and secure in next 2 months, right? That's the point. So it's a constant process like any other process, and enforce use of trusted images that we talked about, right? Moving forward, the Azure networking is also a very intense topic. Basically, Azure offers two different networking options, as you already know. One is the basic networking or KubeNet networking, and the second is advanced networking or CNI networking, right? I'm not going to read all this for you, but as an organization, you need to define which networking option you need to prefer. If you ask my personal view here, just because the basic networking does not support the network policies, I would not probably consider basic networking from my perspective, because I need to use network policies for the pod network segregation, and that itself is a key decisive factor for me to use Azure CNI. Obviously, it has got a little bit more complexity because you need to manage three sets of IPs there. For some organizations, it could be very challenging, but the advantage that you're getting in advanced CNI obviously may force you to go and choose the CNI option. It depends on you and your organization again. Keep in mind that even the basic networking, the kubenet networking, can use an existing VNet, right? So if your only requirement is to use the existing VNet and that's what you're forcing your CNI to your organization, that may not be the case. You could still accomplish that with the basic networking too. So that's an important consideration when you're making the decision between advanced versus basic networking component. Now, as we talked about in our introductory security slide here, that you need to go from layer to layer. We started from master, API, etcd, right? We went into container, we went into the parts. Um, Now we went into the container registry, right? So we have been following a very chronological method of defining our security layers here. Now, when you are putting your workload, whether these are applications or APIs, into your AKS cluster, we have definitely need to protect these applications, right? So how do we do that? So you have to come with your requirements for an example, requirements in your environment or organization, right? We talked about advanced and basic networking. We also need to see whether your organization is comfortable exposing public IPs for your AKS cluster. The reason this is important, because if all internet ingress and egress is coming through that public IP, then you do not have the ability to monitor that traffic. Generally, most organization, especially medium and large size organization, would require and warrant all traffic to go through their firewalls or NVAs, so that they have a proper control and monitoring capabilities on that network traffic. If that's the case, it throws certain challenges to you, right? We will talk about it. You need to also look into your web access firewall, where and how you would be using web access firewall. Would application gateway offered by Microsoft that also can inject or add web access firewall capabilities is a proper solution for you, or you need to think about third party web access firewall such as an Akamai, right? That's again a organization based decision that has to be injected and incorporated into your AKS strategy. We'll also talk about the API management gateway. If you are hosting APIs in your AKS cluster, which API management gateway you could use? You could definitely use Azure API management gateway, or if your organization decides to use third-party API management gateway, as for an example SAP, that you need to add into your solution. You need to also define that whether the routing, the web routing in your AKS cluster would be done just through the application gateways, or you need to also use the ingress controller. Ingress controllers is a preferred way of doing the web-based routing, which is a kind of a load balancer within the AKS. If you are not familiar, you may watch my other technical videos where you would see that how we use it. But that's another decision point, right? So your high availability, how we address that in terms of networking, in terms of your application web access firewall and API. All these has to be injected into your strategy. How your north-south traffic is going to be, how you're going to use the NSGs here, right? What's your east-west traffic within the AKS cluster? Basically, when you're talking the traffic between different parts. These are very important considerations, where your firewalls are placed inside your Azure in the same subscription, same resource group, and different resource group, different VNets, right? So these are the required considerations that you need to look into. But it becomes more complex once you understand the Azure limitations. So especially when you're designing the network for around your application and APIs, you also need to understand the Azure limitations, right? So AKS uses Azure load balancers pretty much, right? When you deploy a service in AKS, that is exposed, especially if you have to expose it to the external world. It is to be, and you're using a load balancer type IP, it would create a Azure load balancer. Now, First thing is that the Azure load balancer that are created. So what I was trying to say, unless you specify, these load balancers are created as a public ALB, and that means you would have a public IP which may not meet your requirement, especially if you are not comfortable exposing your public IP address directly to these applications, right? That's the showstopper right there. So you need to create a private ALB. Secondly, and that you could accomplish by specifying it when you create a service, right? So that's not a problem. But ALB or Azure Load Balancer in general has a issue, right? First of all, Azure Kubernetes Services only provisions the ALB with a basic SKU, right? And why it is so important is that ALBs with basic SKU has a limitation within Azure. It is not just limited to AKS, it's a general limitation with Azure Load Balancer that basic ALBs front-end IP address is not reachable by other VNets in the organization. So if you're doing VNet peering, that front-end IP is not reachable. That creates a challenge. And how do you deal with that challenge, right? Thirdly, that Microsoft has recognized that, and Microsoft has come out with a workaround for this ALB, and they said if you use a standard ALB and you use the global VNet peering, then that issue, that challenge that we have of front-end IP is resolved, and that's a workaround, and that's fair, that is doable. So Microsoft came out with a AKS preview mode where now you have the ability to provision these Azure load balancers with a standard SKU. The challenge is that in the AKS preview, when you do that, it creates by default before even you attempt to create a service, just creating a cluster would create an ALB with a standard SKU, but it is a public ALB. That means you're exposing the public IP address directly. And unfortunately, if you try to remove that ALB, your cluster would crash because all outbound traffic to internet, all egress traffic is also going through that ALB. So AKS preview mode allows you to do that, but it defeats the purpose of the not exposing the public IP. You could do some configuration and settings there. That's a little bit more tricky, and I don't think that organization probably would go that route. As I said, Microsoft is still working on a project to create a private AKS cluster. We don't know their ETA of GA or a preview mode yet, but that is still to be seen. And that creates a real challenge. So how we accomplish that in an example here, in the next slide, this is a very busy slide, but what we try to do here is we created basically on an AKS cluster, we are hosting three different applications, or let's just go step by step. So we have one application is demo AKS agtest.club. The second application running on the AKS cluster is agtest-club/demo. The third application, front-end web app, is micro AKS agtest club. This is an Angular application, and what it also has is that if you look into here, this front-end web app, front-end services talk to the data API. This is where here, and the data API is also exposed publicly. Data API internally talks to the internal service, which is a MongoDB. This is not exposed so that users can get it. So what's the flow? Quickly, right? So basically, we know that we have an ALB that has a challenge, so we introduce the application gateway in front of ALB, which takes care of that challenge of the front-end IP that we talked in the last slide. And application gateway, being a layer 7 device, doesn't have that VNet, the front-end IP limitation. So we still have this a private application gateway, internal application gateway, and an internal load balancer. So we are not exposing public IP. From an end user perspective, when he goes to the demo AKS agtest.club, he goes to our web access firewall. Web access firewall is Akamai in this case. It goes to the public IP of your Palo Alto, so we can monitor the network traffic here, and the Palo Alto nets it to the private IP of the application gateway. Application gateway in the backend is talking to the three different pools here, the backend pools in the ALB. One is, the top one is for the ingress controller. Second one is for the front-end web app for the microservices, and the third one is for the data API. So when the user is coming to demo AKS easy test, the application gateway web-based URL routing is sending it to the demo AKS BSN connect.com, which is actually sending it to the ingress controller inside the AKS, and ingress controller actually sends it to the appropriate service, right? Similarly, when it goes to the slash demo, it goes all the way the same route, comes in here, comes to the ingress controller, and now ingress controller is routing it to the appropriate service. So this web-based routing here, URL-based routing is pretty much accomplished here at the ingress controller for these two applications. To understand better the Angular application here, in case of micro AKS easytest.club, user comes the same way all the way here. Now it hits the backend pool, which is the micro AKS here. And here the routing is done directly through the application gateway, and it directly sends the traffic to the data API here, right? Oh, sorry, on the front end web app here. Because it is an Angular client, the user gets the environmental variable to get to the data API. So now the user creates a second session to the API management gateway, which is the SAP here, SAP API management gateway, which comes back again to this route. Routing is configured here, and it hits the data API service, which is again being routed through application gateway. For this, we are not using the ingress controller, and it gets to the data API. Data API in turns internally connects to the MongoDB, and user gets all the access, right? So it meets all our requirements that we are talking about, not exposing public IPs. It takes care of our, the private ALB, the front end IP issues. It does not expose the multiple public IPs on your Palo Alto or the firewall, so limiting the surface attack from the security perspective as well. Right, so this is an example that how you can secure your APIs and applications within the AKS from the networking perspective. Moving forward, you need to do the cluster update. Keep in mind that cluster update is different than the nodes update. Node updates are being done and responsible from responsibilities on Microsoft. As an organization, you would be required to only ensure and control the reboot if required, but node updates are Microsoft challenge, right? But when you need to update a cluster from one version to another, that's where you need to define that how that should be part of your strategy here, right? So if you're using a green blue strategy, it's no brainer that you would upgrade your standby cluster, making sure and testing successfully everything is good. If that is successful, that update is successful, you bring that in production, destroy the existing one, existing production cluster, recreate the standby, right? If it is not using the green blue strategy, then probably the best route is to provision a new replica cluster kind of from your DevOps process. Update this newly provisioned without touching the production cluster. Update this, making sure everything is good, healthy, and up and running. Then you convert this newly provisioned cluster as your production cluster and destroy the old cluster that you have been, right? So that's what the cluster update strategy is, but this should be included in your strategy. It's already over 1 hour. I wanted to keep it under 1 hour. So Azure Kubernetes services auditing and monitoring. Azure Monitor is the tool that we prefer. Most of you are familiar with Azure Monitor. You can very easily integrate Azure Monitor with AKS. All the metrics are given here. I'm not going to read it for you, but you have to include it into your strategy and define all required appropriate notification alert from Azure Monitor perspective. Azure AC, why I gave you this Microsoft recommended Azure AC is to ensure that you can map your organization teams with the teams that Microsoft had put together. So if you click on each of these teams here, you would see what the team is and what the responsibilities are. It may not match your organization, but once you start looking into, you can map these to your organization requirement, right? So you may not have all these teams, but you can mix and match and make sure that your org chart matches with these kind of for a RACI perspective. Moving forward here, this is a generalized picture of Azure RACI. I'm not going to read it. It's for you to go through it. But moving forward is what is more important is AKS RACI. Again, this is a busy slide. I have just put a draft here. I'm not going to read everything for you, but if you see here, the different teams like cloud strategy team, cloud adoption team, cloud operations team, cloud governance team, cloud platform team, cloud automation team, cloud network team, cloud DevOps, cloud security. This is where you need to organize it in your organization. How you do that, that's entirely your area. But most importantly, the work stream and activities that you need to look into carefully and plan it before you get into the AKS deployment, right? And I think this is an over an hour video. I thank you all for watching it. This is actually a concluding slide from my perspective. I hope it is helpful. You have the PDF version in the description of this video. Um, Thank you for watching. Thank you for your patience. Hope it is helpful. Have a wonderful day. Bye bye.